This is the last but not least podcast episode dedicated to computer software assurance, where we took the inverted pyramid level by level. And the last level is documentation. With computer systems validation, documentation got the focus, but with computer software assurance, critical thinking gets put at the top of the list, and then documentation is the end result. But did CSA miss the mark, or is CSA missing the mark by calling it documentation at all? In this podcast, we'll explore the documentation aspect of computer software assurance. We've been buried with documentation. Again, I've mentioned it several times that some may feel the higher the stack of documentation, the more paper you generate, the better the validation is. But that is not the case. What that means is you just generated a lot of paper. And when we look at documentation itself, what are we really trying to prove? We need the documentation because the old adage is, if it isn't documented, it didn't happen. But what do we need the documentation for? One aspect is we need the documentation to prove that the system has been validated, the objective evidence to prove the system performs as intended. Performs as intended is based upon the requirements. First, user requirements to demonstrate performance, functional requirements to demonstrate the system is operating functionally in all aspects that are required based upon the user requirements, and then the installation, which is related to the design requirements to prove that the system was installed properly. So you install it, with the IQ, you perform the operational OQ to demonstrate that all of the functions and features are working, and then performance qualification to finally demonstrate the system is performing as the user intends to use the system consistently throughout the life of the system. But is that all that documentation is doing? Well, take for instance the installation qualification document. And with that, we do the IQ, but is it just for validation? No, the IQ can be used to install the system later if need be. Disaster recovery, business continuity, for example. You have a disaster, you need to reinstall the system, so you use the IQ. So the IQ isn't an artifact, a document that you generate, and then you just file it away in an archive. Rather, the IQ is a document that you can use each time you need to install or upgrade that system. More so the reason to have an electronic system, because you don't want to go to a document archive, or document management system, pull the IQ document, print it off in PDF format, and then walk through the steps. Why do you do that or need to do that if you can have a validation electronic, if you've digitized your validation? If you've digitized your validation, then the IQ protocol should be readily accessible so that you could perform the IQ again. Or if you're in a cloud-based environment, you can perform the IQ by running scripts, and that is feasible. The technology is here today, and others are actually already doing that. So the IQ, does it really have to be a document, or can the IQ be a script that's controlled that will automatically deploy the system and deploy the configuration of the system? If you don't have that, can the IQ be digitized and available as records in an electronic validation lifecycle management system so that when you get ready to perform the IQ again, you just pull up that information, those records, and it will present to you what appears to be an installation qualification. Sure, you could render it as a PDF and it will look like the IQ that we've traditionally seen in the past, or hopefully made improvements upon. You can render that PDF, but you actually have the IQ as records in a system. The emphasis is on records stored in a database management system, records that are related to each other, hence you get relational database management system. That's the point, that documentation is really the end result. But really, as we move forward into Pharma 4.0 and digitizing validation, it's really records that we're focused on more so, or should be focused on, because with records, I can sort information, query information, generate PDFs. I could do so much more. If I have a document and only the document, then that's what I have, just a document, a PDF. But records could give us so much more power and benefit. Then we get to the OQ. CSA encourages a risk-based approach and also encourages us to look at other ways of testing a system, like ad hoc testing, exploratory testing, and automated testing. With automated testing, again, you have a script. Just like with the IQ, you could have a script to deploy the infrastructure if it's in a cloud-based or virtual environment. With the OQ, you can do automated testing, which also is based upon a script. And that script will be run and test the system and make sure all of the features and functions perform successfully. You can, if the script is written properly, you can test all of the features in a matter of minutes, maybe hour, depending upon how complex the script is. But it doesn't take days and days that you would typically experience with the traditional computer system validation, where you have a 100-page OQ document and you're executing that paper-based manually. That takes time. With an automated test, you're going to be running the script. The script will test the functionality of the system and generate something. That something could be a log file. It could be capturing evidence of screenshots if that is included in the test script. And so the point is that the OQ in an automated environment is really just a script, an automated script to run the automated test. The end result is the log file. Now, we're used to seeing an OQ in the traditional form, but what you can do is you can grab the output, the log file, you can grab whatever the successful execution of the test steps, and you can automatically populate a protocol that's inside of a digitized validation lifecycle management system, and that protocol is actually the OQ, but it's not a document. It comes in as records, and those records are routed through the system, reviewed and approved, automatically populated into the system. And from those records, you can generate whatever you want, a report, a summary report. You can generate a actual PDF that looks like our traditional OQs. So again, the point is records are the focus, not documentation. Documentation is something that's the end result, but we can do so much more with records. And so with CSA, I like to look at the last level as records, because from that I can generate whatever else I need to generate to satisfy the needs of auditors, inspectors internally. And I can use that OQ again and again for regression testing, a patch, periodic review testing of the system to make sure it's still performing. Now let's talk about the performance qualification PQ. Again, this can be done with automated testing, especially with performance if you're trying to make sure the system can perform with a given number of users, because you can simulate multiple users, or you can also demonstrate the system is responsive on the transactions. Now, in a previous podcast, I warned about setting requirements such as system must respond within 5 seconds or 10 seconds. That's good to do if it is required, but don't make up a response time, because if you do make it up and 5 seconds is a nice to have and the system responds in 6 seconds, then you have a deviation. So be careful with performance and identifying specific time frames like seconds or minutes that it must respond. But with the PQ, you can actually automate that whole process, and you can do performance testing based upon numbers of users or the amount of time it takes to do something, if again, that is a requirement. The PQ, much like the OQ, IQ, can be generated especially if it's automated, and that can be something that is recorded as records. The other thing with the PQ is you can perform exploratory testing or ad hoc testing, and you can document that as far as user responses for the exploratory or the ad hoc testing. And the way that you can document that it happened is recording a video, and that video can be objective evidence. So that documented proof isn't a document, it happens to be a video. Now, if you've digitized your validation, you can include that video objective evidence as a test step attachment, and that test step attachment can prove that the step occurred, and then the video on the inside it proves that it actually happened. So that could actually be done with exploratory or ad hoc testing. So you have 5 users recording whatever it is, exploring and doing the ad hoc testing on, and then their videos can be attached. So it is objective evidence that's attached to a record, and that record in total gives documented evidence that something was performed, but it isn't a document. Again, records, stressing records. The final thing I want to mention here is the traceability matrix. If you have digitized your validation and you have your requirements digitized as records, and you have your qualification protocols, installation, operational performance digitized as records, now you can automate the traceability matrix, the generation of the traceability matrix. Why? Because everything is records in the system. Requirements, test steps, they're records. And with a relational database management system, you can relate one record to another, provided you have the right keys, such as requirement number, test step number. So if you include a test step, a requirement inside of a test step, then you can reference back to that actual requirement. You could also reference requirements to requirements. So user requirements relate to functional, functional to design, and vice versa. And those can relate to their respective qualification protocols, like user requirements to performance, functional requirements to operational qualification, and then the design specification to the IQ, the installation qualification. So as you can see, it's the records that are important, and that's the point I wanted to drive home. CSA, the flipped paradigm, is critical thinking, assurance needs, testing, and documentation. So I like to say that it is the same thing, critical thinking, assurance needs, testing, and records. And those records can produce the documentation. Now, I haven't talked about the validation plan and the validation summary report. In that case, that's something you can write up, although some systems will automatically generate that for you. However, I believe that human intelligence is best at generating the validation plan and the summary report. You can leverage what a digitized validation system can generate for you automatically, but put some human intelligence in there, because the validation plan, what you say you're going to do, is extremely important and takes intelligence. And the summary report, what actually happened, it takes intelligence to summarize in a proper way and clarify exactly what happened and the impact, if any, and if it is an impact, how it was resolved. So in those cases, sure, you could have a document. The validation plan can be like a document. The summary report be like a document. But as for everything else in between there, the requirements, the user functional and design, and the protocols, installation, operational performance, those can be records, and those records can generate the documented evidence. By the way, there's no requirement that says you must call it URS, FS, DS, IQ, OQ, PQ. There's no requirement as long as you show equivalency. And showing equivalency is extremely important, because if you have an external party, such as an auditor or an inspector, that's used to looking at those traditional documents, then you'll have to demonstrate that what you're doing, if you're not calling it IQ, OQ, PQ, URS, FSD. If you're not calling it those things, you have to demonstrate that all bases are covered and what you are doing is equivalent to what has been done traditionally or ideally better. Hope you enjoyed this CSA series on of podcast episodes. And the next podcast, there's several things that are bouncing around. One, I've already mentioned requirements, and then edge computing is really taking hold, and there's some movement in that area. And I think that edge computing is a topic that we really need to dive a little deeper in. The next few podcasts will be covering requirements and also edge computing, amongst other things. So stay tuned, come back, spread the word, share this with your colleagues, and I would love to hear feedback as well if you think that there would be a good podcast that needs to be covered, or if you'd like to be a guest, please let me know.